The objective today is to look at the derivative of inverse trig functions. Before we just jump straight into the calculus derivatives though, I want to do a brief review of what is an inverse trig function, how do we evaluate it, and things like that. So there are three basic ones we want to focus on first. That is arc sine, arc cosine, and arc tangent. So with arc sine, this is one of the first ones you ever learned in pre-calculus or trigonometry. So with the range of arc sine, the range goes from negative pi halves to positive pi halves. This means on a graph, we are graphing between negative pi halves and positive pi halves, including every value in between. And since it is a bracket, the endpoints are included as well. So we have negative pi halves down here, positive pi halves up there. With arc cosine, the range goes between 0 and pi. That means it starts over here on the right and moves over to pi on the left. And because it's a bracket, we include the endpoints and every value in between. With arc tangent though, notice the range is in parentheses. That means it's still the same range as arc sine, going from negative pi halves to positive pi halves at the top. But with the negative pi over 2, because it is a parenthesis, that is actually excluded from the range. So we have to use an open circle there. Same thing for positive pi over 2. It'll include everything in between, it just does not include the endpoints here. So when I'm trying to evaluate an inverse trig function, what you're thinking about doing is you're actually using the unit circle going backwards. So for instance, if I'm looking for the arc sine of negative 1/2, in my mind I want to ask myself what angle on the unit circle would give me the sine value of negative 1/2. Well, first I want to determine where is it going to be 1/2. So the angle where I have the sine of that angle is equal to 1/2 is going to be pi over 6 based off of the unit circle. But because it's negative and the range of arc sine goes between negative pi over 2 to positive pi over 2, this means in order for it to be negative, it has to be negative pi over 6. So if I was to graph it, negative pi over 6 is down here, and the sine value there would be that negative 1/2. In terms of arc cosine of 0, if I ask myself where on the unit circle do I get cosine of that angle is equal to 0, well that would have to be at pi over 2, because cosine of pi over 2 is equal to 0. So working backwards, arc cosine of 0 is pi over 2. Now a lot of times we don't actually write the word arc in front. It could just have what looks like an exponent of negative 1. That means the same thing as arc tangent. You could also read that as inverse tangent of root 3. And again, using the unit circle going backwards, the angle that gives me tangent of that spot is equal to root 3 is pi over 3. And because it's positive, I can keep that as positive pi over 3. Now the last one, inverse sine of 0.3. 0.3 is not on the unit circle, so this is a calculator problem. When typing this in your calculator, make sure that you are in radian mode, otherwise you will not get the correct answer. So all I need to do is just make sure I can type that in my calculator, and this would give me 0.305. We are always going to round to 3 decimal places. So we got a couple properties. Sine and arc sine are inverses of each other, which means if I want to evaluate the sine of arc sine of x, well, inverse functions mean they basically undo each other. So the sine of arc sine of x, essentially that sine and arc sine sort of basically cancel out, leaving me with just the inside of x. Same thing would be true if I have the locations reversed. Let's say I have arc sine of sine of y. I'm just going to change the variable here just to show us a different problem. Arc sine and sine, again, just basically cancel each other out, leaving me with that inside of y. So inverse functions just undo each other, simplifying our work. So let's say I want to solve one. I want to solve arctan of 2x minus 3 is equal to pi over 4. Well, the first step I need to do is actually get rid of the arctangent. So I can get rid of the arctangent by using properties and taking the tangent on both sides. So if I take the tangent of the left-hand side, that is just going to give me the inside of 2x minus 3 equals the tangent of pi over 4. Well, tangent of pi over 4 is on that unit circle, and so tangent of pi over 4 is equal to 1. So from here, it's just really easy to solve for x, and x would equal 2. Now, let's say I had something a little bit more complicated, where I have more variables and not as many numbers. So that would be like this problem. It says, given y is equal to arc sine of x, find the cosine of y. Well, it looks a little confusing because I have a lot of different variables here. So first thing I want to do is just deal with that y is equal to arc sine of x. If I rearrange this so that I no longer have arc sine, I'm going to do that by taking the sine of both sides. So this will give me sine of y is equal to x. So from there, I can actually go to the side and draw a right triangle to help me solve the rest of the problem. So this is telling me sine of y is equal to x. Well, this is the same thing as x over 1. And if you think about sine, sine is opposite over hypotenuse. So if my angle is y, the opposite side has a length of x, and the hypotenuse has a length of 1. My goal is to determine what is the cosine of y. Well, cosine is adjacent over hypotenuse, so I don't have the adjacent side. I can find the adjacent side, though, using Pythagorean theorem, so a squared plus b squared is equal to c squared. And using Pythagorean theorem, which I'm not going to write all the steps for that, I end up with the square root of 1 minus x squared. So if I go back and I'm trying to determine what is cosine of y, well, cosine, like I said, is adjacent over hypotenuse. The adjacent side is root 1 minus x squared over the hypotenuse is 1. So cosine of y is root 1 minus x squared, and that's my final answer. So let's look at another one similar to that. So given y is equal to arc secant of root 5 over 2, find tangent of y. So again, if I work off of this, I can take the secant of both sides. So secant y is equal to root 5 over 2. Well, secant is the same thing as the reciprocal of cosine. So cosine of y, therefore, is 2 over root 5. I'm going to go to the side and draw a right triangle. My angle is y. And cosine of y is equal to 2 over root 5. Well, that's the adjacent over hypotenuse. So 2 over root 5. I can label both of those sides of the triangle. And again, using Pythagorean theorem, I can find the missing length, which would be 1 in this case. So then if I'm trying to determine what is tangent of y, well, tangent of y is opposite over adjacent, which the opposite would be 1, adjacent is 2. So 1/2 is my final answer. So that's the review of like the pre-calculus or the trigonometry side of everything for inverse trig functions. The focus today, though, really needs to be on how do you calculate the derivative for calculus. So I want to calculate the derivative of all 6 functions. Now, there are some tricks to memorizing this, which I do want to talk you through. So first of all, the ones on the left-hand column, those are the 3 you really want to focus on. They're going to be the most important ones because the 3 on the right-hand column just follow from the left. So notice, with your arc sine, you have u prime, where u is a function of x, over the root 1 minus u squared. The derivative arctangent of u is u prime over 1 plus u squared. Arc secant's derivative is u prime over the absolute value of u times the root u squared minus 1. And then with arc cosine, arc cotangent, and arc cosecant, they're all the same thing as what's on the left, but notice they all begin with a negative. So a couple tricks for memorizing this. So first of all, notice all 3 over here have a negative coefficient on the top. That's because when I look at what I'm differentiating, all 3 begin with the letter c. So if it begins with the letter c, the derivative will be negative. Very similar to basic trig functions. They also have that same pattern. Then if I look at like patterns between pairs, sine and cosine usually go together. Notice arc sine has the same derivative as arc cosine, the only difference being arc cosine is negative. arc tangent has the same derivative as arc cotangent, the only difference being arc cotangent's negative. And the derivative of arc secant is the same as arc cosecant, the only difference being arc cosecant begins with a negative. Now a couple more helpful tips. Arc tangent is the only one without a root, a square root. Same thing with arc cotangent because it partners or pairs with arc tangent. So those two are the only ones without a root. Arc sine and arc secant both have the root, but the order of how it is set up on the inside is different. So if we begin with the constant and then subtract the function of u, it goes with arc sine. If you have the function of u in absolute value followed by u being squared on the inside, then it's arc secant. So here you got like a repetition of u, whereas with arc sine, you just begin with the constant minus the function. All of them have u prime on top because u is a function of x, so technically that makes each of these a chain rule problem. And so you have the chain rule when you take the derivative doing 1 over root 1 minus u squared times the derivative of the inside, which the derivative of the inside is your u prime. So now that we've looked at the formulas, we want to practice a couple of these problems, of course. So the first one says, differentiate arc sine of 2x. So my u is that 2x. So then the derivative of arc sine says we do u prime on top, which is 2, over the square root of 1 minus u squared. So root 1 minus 2x quantity squared. If it's free response, leave it like that. If you need to simplify or match it with a multiple choice question, of course, you can go to 2 over 1 minus 4x squared. So here's another one. We want to differentiate arc tangent of 3x. So that 3x is my u, and so when I differentiate 3x, u prime goes to 3 over 1 plus u squared, so 3x quantity squared, which simplifies down to 3 over 1 plus 9x squared. So then the next one, take the derivative of arc sine of root x. Keep in mind root x is the same thing as x to the 1/2. That might make it easier for you to differentiate. So u prime in this case, I have to use power rule, 1/2 x to negative 1/2 over root 1 minus x to the 1/2 quantity squared. Again, if this is free response, you can leave it like that. If I need to simplify, I can bring the 2 and the root x to the bottom because it was x to negative 1/2. Negative exponent moves it to the bottom. And then from there, I have 1 minus x on the inside of the other root. Those could be combined together to become 1 over 2 root x minus x squared. And beyond that, I really can't simplify much further. So last example, take the derivative of arc secant of e to the 2x. So the derivative of e to the 2x is 2e to the 2x over, now arc secant says on the bottom you need the absolute value of your u, so absolute value of e to the 2x, times the root of your u squared, so e to the 2x squared minus 1. This one actually simplifies pretty well if you need to take it further. So with your e to the 2x, keep in mind that e to the 2x is already positive because that's an exponential function above the x-axis. So really, these are going to cancel out, and then that would leave me with 2 only on top, the square root of e to the 4x minus 1 on the bottom. So hopefully that helps you out with a basic understanding of just the review of inverse trig functions as well as looking at their derivatives.